Good morning, everybody. Hopefully you guys had a good weekend. If you could give me a green check mark so I know you're with me in Blackboard. And I'll mention a few things and then we'll get started. Looks like most people are in there, maybe a few more coming in. What time did Miss Wood say we were going to get started at today? Couple more seconds. All right, I think that's everyone. Just want to mention a few things about where we are, where we're going. We are just starting Unit 4. So on, not Thursday, because we didn't have class on Thursday, on Wednesday last week, we began Unit 4. And a lot of the stuff you see in Unit 4 was stuff that you've probably already seen before. So what I'm going to do is just mention a few things. Next week on Monday, the 9th, we're going to have our midterm exam at Central Gym. And there is a review that goes along with that, so you guys can prepare a bit for it. One thing about the review is it assumes that we've finished all of Unit 4 going into the review. So what I'm going to do is I'm going to say that everything up till today's class will be on the midterm. So everything we've done from the beginning all the way till today, the end of today's block, will be on the midterm. And then everything after today will not appear on the midterm. So that'll give you guys some time to review some of the stuff that we've done before and things like that. And today's lesson is kind of almost two lessons in one. I don't like how the course kind of broke it up, so I'm going to try to put them together. The ideas are the same, and you'll see what I mean here in a second about that. It's basically the distributive principle of multiplication and combining like terms and things like that. Stuff that we've done a lot of in the past. So this is Unit 4. You guys can see this when you log into the course. So we have a bunch of lessons, 5, 6, and 7. You'll notice that lessons 2 and 3 are expanding polynomials and expanding special polynomials. So I'm going to do both these today in one go because they're essentially the same. I'm not sure why they're even broken up, but they are. So anyways, if we go down a little bit further at the very bottom, these light gray ones, like practice area and midterm exam part A and B, you guys can't see these. This is kind of the teacher view. But this midterm exam review package you guys can see. And this review package is, I think it's 9 pages of review for the midterm. And we're going to submit it just like we would submit any other review. So it's kind of going to be like one of the learning guides that you guys have done so far. Now the tricky bit here is that we're kind of plugging away at Unit 4 and we're doing this learning guide review stuff at the same time. So it's a bit hectic, I guess. But midterm exam review package, let's open it up, see what this looks like. You can see here, as part of your preparation for your exam, complete the following assignments. So the assignment's here. If you click on it, it opens a Word document. If you're having issues with that, I can upload the PDF as well. But click on assignment here. And let's take a look at what's in here. So you can see all the stuff we've gone through. Instructions, use a pencil, write the answers down. Number system stuff we've done. Some things you need to know. So it basically tells you what you need to know. Place the following in a number line. We remember doing that. Has some general concept type questions. Evaluate to the nearest hundredth using all of these radicals. Simplify, and then measurement stuff we did, all of that, converting metric imperial using your formula sheets, the vernier caliper questions, converting, some basic word stuff, all of your exponent laws. We just finished this stuff, so it should be fresh in our minds, and fractional exponents. Polynomials, this is the stuff we started last week. Greatest common factor, lowest common multiple stuff we haven't we haven't seen yet. Some of the stuff have, some we have not. So by the end of today's class, we should be up to here. This basically page 6. Everything on page 7 down below here, this stuff, we can do this question, but we probably won't get to number 6 here. So if you do the first 6 pages of the review and not worry about page 7 and 8, that will be everything we were going to finish up to the end of today. So the first 6 pages. You don't need to worry about page 7, 8, and then of course page 9 is just the answers to all these problems. So 6 pages of that learning guide review midterm thing, that's what you're going to be responsible for. Now, this week I won't go through a ton of stuff for Unit 4. We'll go through a bunch of stuff today, but I'll spend at least one day going over any questions you have on the review. But this is stuff you've all seen before. This is stuff you should have encountered, you should have learned already. So I'm not going to spend a lot of time reteaching this stuff. The lessons are in the course. There's the actual videos that are built into the course. There's the videos that I make here with you guys live. So all of the stuff is there. You shouldn't be relearning it. You should be just reviewing it. That's the idea behind the midterm. So just show me what you know. So that's that. Does anybody have any questions about the midterm, about the review here, the learning guide, midterm review, anything like that? Unit 4. Clear out these check marks. Don't see anybody feverishly typing, so I'm gonna hope we're all pretty good. Abby's asking a question perhaps. Just remind you what we did last day on Wednesday's class. We went through simplifying polynomials. So we talked about the difference between monomials, binomials, trinomials. We talked a bit about the degree of a polynomial. So the greatest exponent gives you the degree of your polynomial. And some other things along there. Sorry, I had my chat on the wrong window, so I wasn't catching what you guys were asking, but I have it now. We did some evaluating by substituting. We did a bunch of expanding and combining like terms. So, okay, perfect. So the questions are, can we look at the past lessons to help us with the review? Yeah, of course. Any sort of way you want to go about reviewing, you can. Everybody's going to be a bit different. The review isn't a test. It's stuff you've all learned. So if you want to go back and look at other lessons and things like that, by all means, do that. Jade's asking when the review is due. Let's have the review due on Monday. You can either bring it to the midterm, or you can submit it online prior to Monday morning. So if you wanted to, just bring it with you and hand it to me while you're writing your test, I can go through it and just check, see how much you did and how you're doing there. Again, this is stuff we've already learned, so I don't think that we'll run into a ton of problems with it, but you never know. So Monday morning, hopefully that works for you, Jade. Some questions about the learning guide for Unit 4, 1F, and 4C. Okay. Does anybody have any other questions about the learning guide for Unit 4? So Abby's asked a question, if we get there ahead of time, could you look at it and make sure that we're ready for the test? So we'll have some time this week, Abby, to go through the learning guide online. I'll go through any questions you guys have. I'll spend a full day, one full day this week will be just going over questions you have about the learning guide. So hopefully by the Thursday's class, you won't have any sort of questions. It'll be all done already and you won't have to worry about it too much. But yeah, let's say I'll be there, it's a Monday, so I could probably be in Central Gym around 8:30. And that way, if anybody had any questions before the test, I'd be able to help you that way. Unit 4 is going to go on term 1 or 2. That's a good question. Let's put all of Unit 4 on term 2. So everything up until, because we only started one lesson. So all of the term or Unit 4 stuff will go on term 2. Even you might write a few quizzes from Unit 4. And those quizzes only count for about 0.3% of your grade each. So even if you wrote all the Unit 4 quizzes, we're only looking at your grade changing by about 1%, either up or down. So the Unit 4 quizzes aren't gonna, make or break your grade. While we're talking about grades, there's a few of you who are still catching up, which is okay. But we need you guys to be with us moving forward. So basically at the end of Friday's class, or on the end of the day on Friday, it's the last day we're gonna accept work for this term, I'm gonna look at your grades, and basically if you're missing things, those are just gonna be entered as zeros. So if you've missed quizzes, if you've missed learning guides, I don't want to put in zeros for these things, but if you just don't have them done, I have to have an accurate portrayal of your grades. So if there's nothing there, I can't give you a mark for it. It goes in as a 0 until you get it in. And your mark is cumulative, so meaning if you submit that learning guide or thing that you didn't have in later, the 0 gets changed to a grade and your mark goes up. But until then, I don't have any indication of what you've done in terms of that work, so I have to just put in a 0. So missing quizzes and tests and things like that will all be zeros come Friday afternoon. So besides this day, the rest of the week will be review for the midterm? No. We'll have one class for full class of review for the midterm. I'm gonna slowly move through Unit 4, and most of it won't be on the midterm, but we're just gonna kind of plug away at it. Just because we need to keep moving. There's not the luxury of just stopping. We don't have enough classes. I only see you guys 4 days a week for about 4 hours. That's 8 hours every 2 weeks in a regular class. I would see that a regular class for over 10 hours. So we definitely don't have time to just stop and wait for you guys to review for this midterm. So hopefully that helps, clears those up. And if you guys think of anything else you want to ask, you can ask as you think of it. So Taylor had a few questions. Learning Guide 1F and 4C. Here's 1F, and let me find 4C. Okay. Polynomial with 3 terms and a degree of 6. So a polynomial with 3 terms is a trinomial. So we're going to have 3 things. I'm just going to add these 3 things together. I don't know. We can just make them up, right? Yours is going to look different than mine, but you have to have degree 6 in there. So maybe I'll go like 3x to the power of 6. There's my degree 6 taken care of, plus 2x plus 5. So there's 3 terms, and my largest exponent is a 6, so it's a degree 6. There you go. It's trinomial degree 6. The next question we had, jumping around here too much. Write 3 different terms that are like 4a squared b. So I guess we have a number in front, a constant, so maybe 3 x squared c. There's one. We could have like 125y squared times x and 372 x squared z. There we go. There's our 3 terms that are like that. 2x plus 4x, 6 plus 2. Yeah, that looks fine, Taylor. The only thing that I might say is that when we have exponents, we usually start with the highest one at the beginning and then we get lower along the way. So you have your x to the 6 in the middle, which is fine, but we'd probably write it at the front. So that's the only sort of complaint there. Again, it's just kind of how we write math. It's not anything wrong with what you've written. So there you go. I want to move on to lesson 2 here so I can spend a bit of time on this, and then we'll kind of go from there. So I always forget what you guys have and haven't done, and different teachers in grade 9 will cover different things. So I wanted to talk to Mr. Beetlestone, and he mentioned that he did the distributive principle like we're about to do. So some of you have seen this for sure. Others, depending on what math class you're in last year, may or may not have seen this sort of thing. So the distributive property is the feeding the chickens. And the way I described this before is the brackets are kind of like a fence. And if you don't feed all of the chickens within the fence, the chickens will die. And that's sad. So when you're multiplying something outside of the brackets by something inside of the brackets, each term inside the brackets needs to get multiplied by whatever's out front. And then we just spent some time talking about exponent laws and things like that, so you should be pretty comfortable doing these by now. So when I take this 3x times the 2x squared, I'm taking the 3 times the 2, which gives me a 6, and then I have x to the power of 1 times x to the power of 2, which gives me x cubed, adding my exponents together. Then I have 3 times 5, and the 5 is negative, so I get negative 15. X times x is x squared, and 3 times 2 gives me 6, and then my x just comes along for the ride. So that is that. Now I'm just seeing Abby's asking a question here. So is everybody okay with that first question? Have we all seen something like that before? Give me like a thumbs up or a green check or something like that. Just want to see kind of where we're at so I can kind of gauge how fast I can fly through this stuff, or if I should go kind of slow and, thorough explanations, because sometimes students are pretty comfortable with it and other times students are kind of confused by it. So I just kind of want to know where we're at. Well, you guys give me like a green check or a thumbs up or whatever. If you're uncomfortable with it, you've never seen it before, you can throw in an X or something, and then I can go from there. Abby's question was this. I have a question, isn't specific to number, just a general question. So for something like 2xy to the power of 4, would it be degree 4 or 5? The reason I ask is the x has an invisible power of 1. That's a good question. It's something I didn't really talk about when I talked about the degree because they don't come up too much. But if you have 2 variables, and you don't even need to write this down, you won't really encounter them for a long time. If you had something like 2x 4y, and you were asked to write the degree of that, that's going to be degree 5 because you have a 4 here and a 1 here. So this is degree 5. Generally speaking, the questions you deal with in Math 10 are only going to be a single variable type question. It would be really, really mean of them to give you a double variable one like xy or like a to the 5th, b to the 7th, and ask you what degree that is. That's going to be a 12th degree. Generally speaking, you only end up with a single variable. A good question, but something that probably won't be encountered too much. All right, so just taking a peek into chat and into the course, see some thumbs ups. A couple are kind of like meh, kind of in the middle, and nobody really ran away in terror. So I think we're doing okay. There'll be lots of examples of this stuff, so it shouldn't be something that you don't get the hang of eventually. So the next question is a distributive property type question, and there's a bit of a trick to this question. Not necessarily a trick, but between my 2 binomials here, I end up with this negative sign, so I'm subtracting the second binomial. What this really means, hopefully some of you remember this, is that there's a negative 1 here, and that negative 1 is being multiplied by both things inside the bracket. So what I'm doing is I'm distributing the 4 through the first bracket, positive 4, and I'm distributing the negative 1 through the second bracket. Basically, the negative sign here is just going to change the signs of everything inside the bracket. That's just kind of the way it works out. But it's just important to remember that if you see a question that has just subtraction between the two things, you need to distribute a negative 1 or your negative sign through that second bracket. So what I'm going to do is the first one here, I'm going to multiply everything by 4. So I have 4 times 2 gives me 8, and then x, and then 4 times negative 1 is negative 4. And then I have my second bracket where I'm going to take this negative sign, and negative 1 times negative 4x is positive 4x, and negative 1 times positive 2 gives me negative 2. So if I compare just this to above, you can see that all I've done is I've switched my signs for everything in that second set of brackets. Now, once I've distributed that negative 1 through the second set of brackets, I've done all my multiplication. So if I'm following BEDMAS, I've done my brackets, I don't have any exponents, done my division, multiplication. So now I'm at addition and subtraction. So what I'm doing is I'm going to combine my like terms. So this would be kind of a simple question from something we've already seen. We need to look and say, okay, is there anything that is similar? Well, I have this 8x and I have a 4x, so I can combine my x's. And then I have negative 4 and negative 2, which are just constants, numbers, so I can combine those together. So what I'm going to do is exactly that. My 8 and my 4 combined together give me 12 x's. Comes from that. And then I have negative 4 and negative 2 gives me negative 6. So these types of questions, they kind of have 2 steps involved. You're going to do your distribution of your numbers, your multiplication essentially. And then once you've done your multiplication, you need to go at the very end and then combine any like terms together. Alex, I see your question. Maybe I'll get to it at the end of going through this stuff. I'll find some time for that. So that is using the distributive principle. So you're multiplying and then combining like terms. And you'll see that all of these questions are almost identical to what we just did. The next one has this FOIL. Now, I remember I introduced this when we were talking about our radicals section, and some of you had seen it before and some of you had not. So this is distribution, multiplication of polynomials, when you have a binomial times a binomial. And remember, binomials are just things with 2 terms. So this is 1 term, 2 terms, so that's a binomial, 1 term, 2, that's another binomial. So when I'm multiplying binomials, FOIL just is saying, make sure everything gets multiplied by everything else. So the F in FOIL is firsts, and then we have outside, and then inside, and then last. That is what the acronym FOIL stands for. So many of you have seen this. It's just a way for you to remember to not forget multiplying any terms. And just a little thing, if somebody says just FOIL it, then that's essentially what it means. So it only works when you multiply binomials together. So this is what we're going to do. We're going to take our first term. So I'm going to have this 2x to the power of 3. I'm going to multiply by the x. So that's my first. And then the O is the outside. I'm going to take this and multiply it by the outside. So these are my outside terms here and here. And then my I is inside. So I'm going to take this 3 and multiply by the x because these are my inside terms. And then I'm going to multiply the last term. So the last in the first bracket times the last in the second bracket. So that is FOIL. If you kind of look, the term in this 2x cubed gets multiplied by both things in the second bracket, and this 3 gets multiplied by both things in the second bracket. So when we're multiplying, it's just making sure we're multiplying each term by all the other terms in the second bracket. So now I'm just going to do the multiplication. I have 2x cubed times x. So I have 2x to the power of 4. That was my first multiplied. My outside terms are going to be the 2x cubed and the 5. So we're going to have 2 times negative 5 is negative 10 x cubed. And then my inside terms are my 3 and my x. So I'm going to get 3x. And then the L is last. I'm going to take my last terms, the 3 and the negative 5, which gives me negative 15. So at this point, everything's been multiplied by everything else. I've done my FOIL. And what I need to do now is say, are there any like terms I can combine together? Do I have any x's or just numbers that can be added or subtracted together? So if I look, I see I have an x to the power of 4 and an x to the power of 3 and an x and a 15. So there is nothing I can do to combine any of these together. If my exponents were the same, I could combine them, but they're not. My exponents are different. So I have an exponent of 4, an exponent of 3, and an exponent of 1. I can't combine those things together. They're different. So that's it. That's all I can do for that question. So if we look at the next question, we run into kind of the next step. Now I could do like a ton of these FOIL questions, but I don't think you guys would get anything out of it. You just need to basically sit down and practice doing the FOIL or distributing the first bracket through the second bracket. This next question just raises the difficulty up a little bit. Instead of it being a binomial times a binomial, we're multiplying a binomial times a trinomial. So the acronym FOIL doesn't work anymore because now we have 2 terms and then 3 terms. But the sort of principle that we're using it is multiplying each term in the first bracket by each term in the second bracket continues to stay true. So when I'm doing a question like this next one, I'm going to take the 3k, I'm going to multiply it by the k squared, and then I'm going to take the 3k and multiply it by the 2k, and then I'm going to take the 3k and multiply it by the 7. So there is taking that 3k and multiplying it by everything in that second bracket. And I need to do the exact same thing with my 4. So the 4 times the k squared, the 4 times the 2k, and the 4 times the negative 7. So the principle is exactly the same, except I just have 3 terms in the second bracket, and my fancy little acronym FOIL, it doesn't work anymore. So let's do the multiplication. Let's see what happens. So we take that 3k and multiply by the k squared. This is the first term here times the first term. So 3k times k squared gives me 3k. And if I add my exponents of 1 and 2 together, I get 3. So 3k to the power of 3. Then I'm going to multiply my 3k by my negative 2k. So I'm going to get negative 3 times 2 is 6. K to the power of 1 and k to the power of 1 gives me k squared. Then I'm going to take my 3k and multiply it by my negative 7. So 3k times negative 7 is negative 21 times k. So that is the first term multiplied by all 3 terms in the second. Now I need to do the exact same thing with my 4 here. Take my 4 and multiply by my k squared. So maybe I'll do this in red. 4k squared. And take my 4 and multiply by negative 2k. 4 and 2 gives me negative 8k. and then my 4 times my negative 7. So negative 28. So just multiplying everything in the first bracket by everything in the second bracket. Once I get here, I need to combine my like terms. So anything that's similar needs to be combined together. If I have any exponents that are the same, I can combine those. So I look, I have 3k to the power of 3. Do I have any other powers of 3? I do not. What I do have is 6k squared and 4k squared. So I can combine those together. And then I have 21k's and another 8k's. So I can combine those together. So this 3k to the power of 3 can't combine with anything, so I'm just going to bring it along. I have negative 6k squareds plus 4. So negative 6 plus 4 gives me negative 2k squared. Negative 21k minus 8k is negative 29k. And then I have this negative 28. So essentially the 3k just drops down, this 28 drops down, and then I've combined my k's here with my k's here, and I've combined my 4k's here, k squared, sorry, with my k squareds here. Is k 1000? I'm not even sure where that question's coming from, Alex. K is a variable. It could be anything. I could say k is 2. I could say k is negative 7.29. We haven't learned how to solve for k yet. That's kind of something that will happen. Geez, when do we learn to solve these things? The tricky part, Alex, is that the most math questions will have one answer, but these ones are what we call quadratic equations and the like. They have more than one answer. And that becomes really important when you get into calculus, but for now we're just kind of building the foundation for you guys to learn calculus. So there is no answer to the question. K doesn't represent anything yet. We could put any value we wanted in for k. So really, once we get there, that's that. I think I've understood your question a bit better now. Is k 1,000? Like, yeah, so if somebody wrote down like, 5k, that'd be like 5,000. So k, I don't know where that k comes from. Maybe like kilo. Kilo means 1,000. Kilograms, 1,000 grams. A kilometer is 1,000 meters. Kilo is the prefix for 1,000. And k comes from that. That would be my guess, just off the top of my head. I don't know if that's right or not. You can go with it. All right, so that's that. What I wanted to do is, I just want to put in a couple additional questions here. And these are from the practice. There's a bunch of stuff I wanted to change in this lesson, but because I gave it to you guys ahead of time, I couldn't change it because some of you would have one thing and the other, so I just wanted everybody to kind of be on the same page. So I'm going to add, we have A and B. I'm going to add letter C in here. And I'm going to make C look like this. 3 minus 2x cubed times 8x squared. And letter D, I'm going to write in as negative 3 times 2x plus 2 plus 3 times 2x minus 1. And these are just kind of bonus questions. Stuff that comes up in the learning guide that you're going to see that is not necessarily tricky, but I just want you to experience a few different types of questions. Basically, all of the principles that we've learned in the first 2 questions there apply to all the questions. It's just the same thing over and over again. The numbers change, the variables change, but it's always the same. When we're kind of dealing with these things, we can move the things around on you guys and kind of not necessarily try to confuse you, but just expose you to different types of things. So this one, the first one I've written down here, letter C, You'll notice that normally we write something actually in front of the bracket, but in this case it's written behind. Does that necessarily change what we do about the question? No, it's the exact same process. And in fact, I'm just going to draw on my arrow. It's the distributive principle, except instead of this thing being multiplied in front, I'm just going to multiply it going backwards. And there's no right way. If you took this 8x squared and multiplied it by the 3 first, that's fine. Or if you took it and multiplied it by the 2, that's fine. Order of multiplication does not matter. So what I'm going to do is I'm going to go this 8x squared, I'm going to multiply it by the 3 first, just because that seems like fun. 8 times 3 should give me 24 x squared, and then I'm going to do the same thing and multiply it by this. So 2 times 8 is negative 2, negative 8 is negative 16, x to the power of 3 and x to the power of 2, add those together, I get x to the power of 5. I look, are there any terms that are similar? Can I collect or combine any like terms? No, there's nothing that's like there, so I can't do anything to further simplify it. I've multiplied the 8x squared by both terms inside of the brackets, feeding my chickens, if you will, and that's all I can do. That's it. The next question is kind of like 2 questions combined into one. If you want to think of it this way, I have this red part, if I just leave it for a second. So I'm multiplying the negative 3, I'm distributing it through here, and then I'm going to take this positive 3 and distribute it through here, and then I'm going to combine any like terms I may end up with. It's just 2 sort of questions in one. So negative 3 times positive 2 is going to give me negative 6, and then I have an x. Negative 3 times positive 2 again is going to give me negative 6, but no x this time. So that's my first bracket with the 3 distributed through there. And in the second bracket, I'm going to multiply the 3 through again. So the 3 times the 2 gives me positive 6x, and the 3 times the negative 1 gives me negative 3. So I have 4 terms. I've done all my multiplication. So now I am down to adding and subtracting, or combining like terms. So what terms do I have that are similar? I have x's here, I have x's here, I have negative 6, and I have negative 3. So if I'm combining my like terms, I'm going to combine my x's, and I'm going to combine just my regular numbers, see where I end up. Negative 6x here and positive 6x, what happens there? I had 6, take away 6, so I end up with 0 x's, and 0 times x just gives me 0. So I'm not even going to write it in, because it just goes away. I have negative 6 and negative 3, add them together, I end up with negative 9. And that is that thing simplified. So you'll see some questions like those. Hopefully they're not too difficult for you. There's one little note at the bottom of the page here, and it says one way to check that a product is likely correct is to substitute a number in for the variable in the original expression and then in the answer. So if I look at any one of these questions that I've done here, maybe if I just look at this letter C here, let's pick a number for the variable x. We can make x maybe 1. I like multiplying by 1, so I'm going to pick 1. So the question started off as 3 minus 2x cubed times 8x squared. If I substitute a 1 into the question, so I get 3 times 2 times 1 cubed, 8 times 1 squared, what do I end up with? Well, I get 3 minus 2 is 1, 8 minus 1, or 8 times 1 is 8, and 1 times 8 is 8. So this is just a way to check if these answers are right. What about if I substituted into what I thought was the answer? So I'm going to check my answer now. I'm going to go 24 times 1 squared, minus 16 times 1 to the power of 5. Well, that's just going to be 24 minus 16, and 24 minus 16 is 8. So in both cases, I end up with number 8. I could pick any value I wanted for x. I could put in x is 17, and I could do the same thing. I wouldn't pick 17 because 17 to the 5th power is going to be a really big number, and I don't like dealing with big numbers, so I'm going to pick things like 1 or 0 to check my answers always. 0 would have worked just as well to check your answer. So if you go through all of these and you pick whatever number you want, you can plug it in and see if the question and what you think is the answer have the same value when you substitute any number in for the x or the y or the z. As long as it's the same number you're putting into the question and the same number you're putting into what you think is the answer, you should end up with the same number all the time. They're the same thing. We're just kind of rearranging everything. We're multiplying, distributing it out, but it's the same equation, just written in 2 different ways. So that's why it should work out that way. And you can do this with any question in this whole entire unit, and you should figure it out that way. On the exam, if we make a mistake but get the right answer for the mistake instead of the right answer for the actual question, will we still get partial marks for our work or not? Whew. If we make a mistake but get the right answer for the mistake instead of the right answer for the actual question, I'm not sure I'm following. Maybe I can answer this. I don't know if this addresses your question, Ava, or not. On the exam, there'll be some multiple choice questions, and then there'll be a few written questions if you're talking about the midterm. So I think what you're asking is this, like if you were doing the written section and you got a question wrong, but you did everything right along the way, but maybe just like made a mistake with copying a number down or something like that. Generally speaking, the answer is maybe worth 1 mark or half a mark, and the question's likely going to be, depending on how long it is, out of about 3 marks. So conceivably, you could get the complete wrong answer, and it was just maybe a transcription error, meaning you just wrote down the wrong number, but did everything properly with the wrong number in it. Then you'd end up with 2 out of 3 or 2.5 out of 3 on a question that you got wrong, even though you did everything right. So if you do make like a calculation error along the way, you're likely to lose a mark or half a mark, just depending on the question. That hopefully answers that question. And then another question, would you say that the midterm is about the same difficulty as the provincial? Yes and no. The provincial's weird because I don't get to make it. Nobody gets to see it before it gets distributed, so I have no idea what's going to be on it. You see sort of general types of questions that occur on it again and again and again. They just kind of change the numbers around, but every once in a while there'll be a really strange question that I've never seen before, that you guys have never seen before, and it just happens that way because we don't get to make the test. So I'm not sure what's going to happen on the provincial, so I don't even want to say what it's going to look like. The questions that are based in the course are all based on provincial exam type questions. There's only so many things they can ask you, but at the same time, there's always a few questions that kind of come out of left field that we're just like, you know, where did that come from? How did they come up with that question? So it's kind of weird. It's just the way it is, especially with math. Science and things, a little bit more straightforward. You have your basic definitions, words, you have your basic processes that you talk about. It's kind of hard to have some really strange things, but in math, there's just so many ways they can ask the same question. It's sometimes things that will kind of come out of nowhere. Midterms, I don't know. When will you get your marks back for the midterms? By the end of the next week. So if the midterm's on the 9th, by the 14th, you should have your mark for sure. Just depends on how long it takes me to mark them and how busy I am. 4 days or less though, hopefully. Do we find out what you scored on your provincial exams? Yes and no. They'll post your results on the ministry website. So you enter your student PEN number, your provincial education number. So you have to log in after you create an account. And then your grade will come up. So it'll say like 72% or something like that. You don't know how many questions you got wrong because sometimes they'll drop questions off the test. If 90% of the province got a question wrong, they'll say, okay, maybe that was a poorly worded question or there's something wrong with the question, and they'll just get rid of it. And so sometimes you don't exactly know what you get on the test, but you'll know the percentage compared to the rest of the province, kind of, if that makes sense. The midterm, there's 2 midterms. They're one now and one at the end of the semester. They both count for 25% of your grade. So 2 tests, 25% is like 12% of your grade is this midterm coming up. Hopefully that answers that. All right, I want to get through a few more of these questions before the end of the block. This question actually has a typo in it. I started to do it and no, this one doesn't have a typo. The one on the back page does. We can do this one. Basically, this is 2 trinomials. So you're going to multiply every term in the first bracket by every term in the second bracket. You can't miss any terms. The tricky part is that there's 3 terms and 3 terms, so it gets a bit messy. It gets a bit messy. So what I'm going to do is I'm going to multiply this first term by this term. I'm going to multiply the first term by this term, and I'm going to multiply the first term by this term. After I'm done that, I'm going to take my second term, multiply it by this term, my second term by this term, my second term by this term. And then after I'm done that, I'm going to take my third term, this guy, multiplied by this term, and that term. So I'm going to end up with 9 terms. And it is a bit of work, but nothing terrible. It's just the same thing over and over again. So I'm thinking you guys have the knowledge now to actually do this. So maybe I'll just let you guys have a go at it. I'll give you a 30-second head start, and then I will just be quiet as I'm going through it. And I want you guys to see that you know how to do this stuff. So if you're kind of hesitant and don't really know what to do, just start with the first term, multiply it by all the 3 terms in the second bracket, and that'd be a good start. So here's your 30-second head start. Go. All right, assuming all of that kind of worked out, I didn't make any mistakes in my multiplication, you should have something that kind of looks like this. So I did my best to kind of color coordinate it between the 3 sort of terms. So everything in blue is the 2t multiplied by everything in red was the 4t, and everything in green was this last term, the 3. So after I get here, I need to combine any like terms I have. The first thing I see is this negative 10t to the 4th power. I don't have any other 4th powers, so I'm going to just keep that one and bring it down. T cubed, I have t cubed here, I have a t cubed here, and that's it. So how many do I have? I have 4 and 20. I have 24 t cubes altogether. What else do I have? I have t squared, and I have t squared, and I have another t squared. So my t squareds, negative 2, negative 8, negative 10, negative 15. Did I miss a sign? 24t cubed. Negative 2, negative 8, it's negative 10, negative 15, negative 20, 5, t squared. And then t's. I have 4, I have another 6. So together I have 10 t's. And then I have this lonely little negative 3 hanging around at the end. Whew. So, why do I write a T with a line through it? It's a good question, Alex. It's kind of a math habit. When I write the letter T, when I just write, like I wrote light, I write it like that, light. There's my T. But when I'm doing math, if I had T plus 7T minus 3 plus T, all of a sudden my T's and my plus signs look the same. So it's just kind of a habit to write my T's like this, T plus 7T plus 3 plus T. You can tell the difference between my T's and my pluses that way. So just by doing a lot of math, it's the way you'll see T's written a lot because you don't want to confuse them with plus signs. I'm not going to tell you how to write it. Some people write so neatly that it doesn't really matter. T's look like this and plus signs look like this. You guys can tell that my writing is so messy that nothing will help me. So I just want to make it as simple as possible for you guys to tell the difference. On provincial exams, things like that, the written section isn't a true, really written section. So you don't have to worry about it. It won't ever happen where it's a big deal on an exam or anything like that. So just something I do. All right, we'll have time for a few more of these questions. Like this example number 3 here, multiplying polynomials in more than one variable. It's stuff you've done already. I don't think it deserves a question here, but it is a section that you'll encounter on the learning guide and things like that. So let's do it. Instead of having one variable just like x or t, now we have 2 variables. We have a v and a w. So generally speaking, we have 2 variables and they're together. We write them in alphabetical order. So if we had a's and b's, we'd write a, then b. If we have a v and a w, we're going to write the v and then the w. So here goes. First thing multiplied by the everything in the second bracket. So I have 2v times 3v, which gives me 6v squared. 2v times 2w is 4vw. 2v times 7, negative 14v. So there's my first 3 terms. Then I'm going to multiply a second term by everything in the brackets. Don't want to miss anything. Negative 5 times 3 is negative 15. Again, I'm going to write v and w. Even though the w is in the first term and the v is in the second, we generally speaking will write it in alphabetical order. Order of multiplication doesn't matter, so it doesn't really matter how you write it, but that's just kind of a more proper way, I suppose, of writing it. Negative 5 times the positive 2 gives me negative 10. And I have w times w is w squared. And then negative 5 times negative 7 is positive 35 w. I now need to combine any like terms I have. So v squareds, vw's, w squareds, w's. Do I have any like terms? I think my only like terms are here, my vw and my vw. Everything else is not the same. So the 6v squared will come down. Positive 4 and negative 15 is negative 11 vw minus 14v. I'll put my 35w in here and then negative 10w squared. Just out of habit, doesn't really matter how you do it. That'll work. As long as you have all those terms and you've simplified or combined your VWs together, you're going to be okay. It doesn't really matter what order they're in. Just knowing that on a test, it's going to be multiple choice, and if your terms are not the same as the solutions that are there, you need to be able to kind of think and say, okay, that's the same answer as mine, except my terms are just in a different order. So it's just something that kind of will happen. Looks like we have about 7 minutes left. I want to maybe go through a couple more questions. This was the number 4 here on the next page, was the one that had a typo in it. And as I was going through it, I noticed it and then it was just wrong. So my typo is here, 4k minus 3k. We can just simplify those and that's just 1k. So what we're going to do is we're just going to get rid of the whole question. I wrote a completely new question, something a little easier. So we'll call it 4a, and then I'll write a b over here. So 4a is 5 minus 2x, and then this is squared. And then 4b, well, let's just do 4a for now, and then I'll do b in a second. You're going to see a few questions like this where something is squared. And I've talked about these things before when we were dealing with radicals. If you have something in brackets that's squared, the squared means you're multiplying the thing by itself. So you don't need to write this down. If I had x squared, that's the same as x times x. Or if I have 4 squared, that's the same thing as 4 times 4. So if I have a binomial, would that same rule not apply? And it will. So I'm going to take this 5 minus 2x and write it twice because it's squared. Anything squared is something multiplied by itself. At this point, it's the same as all of the other FOIL questions we've done. You need to multiply each thing in the first bracket by each thing in the second. And it just kind of works out. There's a bit of a trick that you can learn after you do a bunch of them, but we'll just do it as is for now. So we're going to multiply the 5 by both things in the second bracket. So 5 times 5 is 25. 5 times the 2x is negative 10x. So there's my first 2. I'm going to take this 2x and multiply it by, or negative 2x, sorry, by the both terms in the second bracket. So negative 2x times 5 is negative 10x again. And 2 gives me positive 4x squared. Combining like terms, I have these 10x's in the middle here, so I'm going to combine those together. 25 minus 20x plus 4x squared. That is that. You'll notice after you do a bunch of these multiplication type questions that are squared, if you have the squared on the outside, the trick is this. I'll just say it. It might not make a lot of sense right now. You square the first term, so 5 squared gives me 25. You square the second term, this 2x squared gives me 4x squared. And then if I multiply these things together in the middle and double them, I end up with the 20x. So 5 times negative 2 is negative 10x. Doubled, it's 20x. Anytime you're squaring something, it'll always follow that same sort of process. So something that you'll see over time after you've done a few of those type of questions, I wouldn't call it a trick necessarily, just kind of something that you'll just see that happens. They're all kind of common in that regard. Let's do... I don't want to do that one. Let's just jump down to the bottom here. There's one at the bottom. There's another typo in here. This 2 should be a 3. So let's change that to a 3. And I'm going to do this question, then we'll call her a day. Probably won't have enough room for it. We're going to do it anyways. Same thing as I was saying before with squared type questions. If I had something like 4 cubed, that's 4 times 4 times 4. So same thing applies here. I'm going to take this 3x squared minus 2, and I'm going to multiply it by 3x squared minus 2, and then I'm going to multiply it by 3x squared minus 2. And that's a lot of stuff, right? You've got 3 of these things. How am I going to multiply all 3 things at the same time? And the answer is you don't. What you do is you isolate the first 2, or any 2 for that matter. You're going to multiply those together. Just kind of ignore the second one for now. And then you're going to end up with a trinomial. So I'm just going to drop this guy down. It's going to end up actually probably more over here after I multiply the first 2 together. But let's FOIL the first 2. So 3 times 3 is 9. X squared times x squared is x to the 4. 3 times negative 2 is negative 6x squared. And then we end up with the same thing, negative 6x squared. And then plus 4. We take all of that stuff, and I'm just going to bring down this 3x squared minus 2. Just going to come along. Haven't done anything with it yet. I'm going to combine my like terms here. 9x to the 4 minus 12x squared plus 4. And then I still have this 3x squared minus 2. Now at this point, you're taking a trinomial and multiplying it by a binomial. So each thing in the first bracket needs to get multiplied by the second bracket. I have about 1 minute left, so I'm just going to fly through this. Hopefully I don't lose too many of you. 9x to the 4 times 3x squared. 9 and 3 is 27. X to the 6 minus 18x to the 4 minus 36x to the 4 plus 24x squared plus 12x squared minus 8. That was a lot. Combining my like terms, 27x to the 6 I can't do anything with. You'll see that I have x to the 4 here, x to the 4, and I have x squared, x squared. And that's where I end up with that guy. So a bit of a long one, a lot of spots to kind of lose your way, but when you just spend time doing these type of question, it's always the same. You're multiplying, you're adding exponents, you're combining like terms, and that's kind of it. So last day I mentioned on the learning guide where we should be up to. I do realize I gave you guys that midterm review, or it's been there for a while, but you now are aware of it, so I don't want to say you have to do a ton of this stuff, but we finished up to basically almost the end of page 2. Now you should be able to finish up to, this is FOIL, a little more difficult FOIL type question. Using the rectangle method and the column method you'll see in the questions, you don't need to necessarily do the column method or do the area method. If you just want to expand them, you can. If you want to look at the column method or the area method, they're in the actual course lessons. So I'm not going to go through those methods. If you like to use them and you want to use them, great. I'm not going to teach it because I just don't have time and I don't think it's really that important. But some people like those sort of the visual representation of these things. So like for using the area, if you want to just multiply these things together and FOIL them and get the answer, great. If you want to use the area method, look it up, do it that way, that's fine. You should be everything up to algebra tiles. So up to page 5. So this is up to lesson 2 and 3. I haven't talked about algebra tiles, I will. That's kind of where we're at. So next day, if you guys have any questions, I'd love to go through them. I don't want to keep you any longer. So spend some time doing that stuff. We'll say maybe, what's today? Lesson 2. Tomorrow, no. Maybe Wednesday or Thursday's class, I'll do a full review for the midterm review. And I'm not sure. We'll see where I end up with. So either Wednesday or Thursday for sure, we'll just dedicate that whole block to just the unit review, the first 4 units that we've gone through. So everything up to the end of today's class will be on the midterm. Everything from tomorrow and the next day, or the 2 more classes that we do this week on Unit 4, will not be on the midterm. So tonight, I'd recommend you maybe have a little bit of a look at the midterm review, just so you kind of get a feel for what stuff we've gone through. It shouldn't take you a long time because it's all stuff we've done. So I apologize for keeping you extra 2 minutes today, but we'll take it up next day and see where everyone's at. So have a good afternoon, guys, and we'll see you tomorrow.